Hello, for today, our video will be all about mesh analysis, which is under circuits 1. This is actually a very useful method in solving complex circuits that are composed or comprised of multiple sources and multiple current loops. So in mesh analysis, actually, at my version, there are two rules. First is the current passing through the resistor corresponds to a voltage drop, because we all knew the fact that there is actually a voltage drop when a current is passing through a resistor or a load. Okay. Next is the sign of the sources corresponds to the polarity at which they exit, as well as current directions. Okay. So first, for our first example, let's try this one. So here is our example. So there are two voltage sources, the 6 volt and the 8 volt voltage source. And first step is to actually assign the loop currents. So when assigning loop currents, there should they should always be in the same direction. This we denote this as I1, we denote this as I2, and we denote this as I3. Okay. So in this circuit, there are three mesh currents. So for the solution, mesh current, mesh current I1. For mesh current I1, that would be, uh, let's write first I1, and let's gather all the resistors because they will always have the same sign, which is they are voltage drop. Therefore, this would be negative. That is 2 plus 10. That is 10. That is 2 plus 10. That is 12 ohms. And as you can see, when the mesh current I1 enters the 6 volt, it will leave at the positive polarity. Therefore, we will be having a 6 right there, and we equate it to 0. And for the sake of simultaneous equation, because we will be using calculator in order to solve this, because uh, when we solve this manually, this could be a tedious one, but it is actually hard to solve for beginners. So let's equate it. Let's drop this 6 volt. Let's transpose it to the right side. Therefore, this would become uh, negative 12 I1 is equals to negative 6. But I forgot to write that, uh, as you can see at this point, I2, mesh current 2, will also pass through this 2 ohm resistor, as well as this mesh current I3. Therefore, we must have a opposing sign, because this mesh currents will oppose mesh current I1 at this point. Therefore, we write this is positive I2, that is 2 ohms. Again, positive I3, which is actually a voltage source, and we do not need to write that down because there's actually the potential difference between those two mesh currents. So that would be it. That therefore this is 2 I2, and that will be our equation number 1. So for equation number 2, at mesh current mesh current 2 I2, that will be, let's gather all the resistor at this loop, and that will always be negative in our case, because we denote that uh, there will be a voltage drop when a current pass through those resistors. Therefore, that is I2 multiplied by 4. 4 plus 2 plus 1, that is 7. And again, as you can see, I1, that will be positive because that opposes the mesh current I2. I1 multiplied by 2, again positive, I3 times 1, therefore that is I3. And the mesh current I2 exits at the negative side of the voltage source, therefore that will be negative 8. And if we transpose it to the right side, that will become positive. Therefore, the second equation will be 2I1 minus 7I2 plus I3 is equals to 8. That would be our equation number 2. And for mesh current I3, that is nothing but I3, again negative because voltage drop. Let's gather all the resistor. That would be 1 plus 5, that is 6. Again, I2 opposes I3, that will be positive I2 times 1 ohm. Okay. Again, I3, but at this point, the 6 volt will be the potential difference. Therefore, we write it exits at the negative side of the battery. And if we transpose that to the right hand side, that will become positive 6. Okay. Therefore, that would be I2 minus 3 I3 is equals to positive 6. Oops, but there is a correction. There are two voltage source at this loop. Therefore, that would become, let's just write it. That is again 6, negative 6 I3. And it enters at negative side, it leaves at the positive side. Therefore, this is positive 8. Again, it leaves at the negative side. Therefore, this is negative 6 is equals to 0. And at this point, I1 right there, that opposes 6 volt, but we already had written the 6 volt potential. And for I2, it opposes I3. We add I2. Therefore, the final equation would be I2 minus 6I3 is equals to 8 minus 6 is 2. We transpose it to the right hand side, it would become negative 2. Okay. And using simultaneous equation in the calculator, we need to have a correct order. Let's write this as x for I1, x is equals to I1, y is equals to I2, and z is equals to I3. And using simultaneous equation, we will be having the following. I1 is equals to 0.329 amps. I2 is equals to negative 1.026 amps. And I3 is equals to 0.162 amp. So we got a negative value for I2 because what it only means is that the direction of the mesh current I2 is it opposes the correct direction that the circuit is having. Therefore, what we must do is to simply just flip the direction around. Okay, that is the correct direction of mesh current I2. And actually, this simultaneous equation can be solved manually because it is very obvious that we have three equations and three unknowns. Three unknowns are I1, I2, and I3. We have three equations corresponds to this. But for the sake of simplicity and convenience, I used shift solve to solve the following particulars. Okay, so that's all. Thank you for watching. I hope you learned something from this video. Thank you.
Rufus boy, let me love boy, what you know. Rufus boy, let me love boy, what you know. Rufus boy.